Here we go with some examples from our inscribed angles lesson. So let's do some of these guys together. We'll do maybe 3 and 4. So number 3, actually we'll do 4 first. It wants us to find this angle measure right here. Remember, the relationship between these two guys is that this guy is double the inside angle. So we take this guy and times it by 2, and we get the outside angle. So 62. And we're done, that's it. So if we can see that relationship, these guys are pretty smooth. Number 3, let's zoom in a bit more so you can see better. Number 3, we need to find out this arc length right here. We have 360 degrees all the way around in a circle. We have a 120 and a 140. We can add those guys together. 260, subtract from 360, and we have a leftover 100. Well, half of this outside arc is going to be the inside angle. So 100 divided by 2 is 50. Boom, done. That's it. Ta-da. I want to show you guys. Let's do. How many of these ones we need to do? Let's take a look at numbers. Wow, there's a lot of examples down here, aren't there? Let's do number. This one. Well, I want to kind of show you guys how these guys work. So let's just do this guy. Again, there's a lot going on some of these problems. So, right here, see how you've got this DAC arc, or DAC angle uses this arc, and B or CDB uses the same arc. You guys see that? This arc and this guy, same arc. So because those two angles make the same arc, that means these guys are congruent. So we can go 5x minus 1 equals 4x plus 17. It looks like you'd have to solve that and then plug it in for A to find A. And these angles here, ADB uses this top arc. You'll notice ACB uses the same arc, and those are our y values. So you have another algebraic equation, 2y plus 1 equals 3y minus 20. You can solve that. It looks like you do have to substitute it in for angle C to figure out what the problem wants you to find. So again, all you do, figure out what C is and substitute it in, and then solve that little expression, and you're good to go. We are going to cross out 9 and 10 just for fun. There you go, wasn't that fun? And we are going to look at 11 and 12. This guy, maybe I'll do the whole problem for you guys. You have to use the characteristic that if a quadrilateral, that's this guy, is drawn or inscribed in a circle, the opposite angles are supplementary. So that means these guys add to 180. And we can do that in our heads. 11y plus 7y is 18y. And then we've also got these guys adding to 180. And you'll notice we have a minus 5 and a plus 5. Those could cancel and go to 0. So it's really just 3x plus 3x, which would be 6x, equals 180. And we can do both of those guys pretty quick. Boom, done. That's it. Oh, no, it's not. Now I have to substitute it in. If I want to find S, I have to take my x and substitute it in right there. We can probably do the next in our heads though. 3 times 30 is 90. 90 plus 5 is 95. Boom. And for R, 11 times y, y is 10. So the measure of angle R would be 110. Done. Let me see the back. On the back, we can do that one pretty smoothly. These guys are a lot of the same stuff as the other side, aren't they? So let's cross out number 6 and 7. There you go. We'll cross out 6 and 7. Yep, that's about all we got for today. A side note, I do think this 30 here is a distractor. Unless all these guys equal 30, which is possible, I mean, but the way you set up this guy, see how this arc, or this inscribed angle makes this arc, and this inscribed angle makes the same arc? So you know those guys are equal to each other. So we got 2x plus 9 equals 3x plus 4. And we will solve away from here. Oh, I know why they give you that 30. Because angle V hits this guy and angle U also hits that guy. So 30 equals U. There you go. Okay, I was confused why they gave you that 30. Anyway, solve that expression, you'll get your x, substitute your x in for t to figure out the measure of that angle.